Wait a light year. You're telling me that's where gold is made?
That's correct, Aldo. Stick around to find out more. Hi, stargazers. What if I told you that stars can tell us the story of the entire universe? Have you ever wondered what happens to a star when it retires? Or why some stars are more important than others in our history? Stick around because we're going to answer these questions and so much more. Hey there, little stargazers. It's me, Sonia, and guess who's here with me? Yep, it's our fuzzy, cuddly, and sometimes a little too curious friend, Aldo the Spider.
Hey everyone, what's up? Sonia, did you know stars are basically the sky's way of decorating? They're like shiny stickers, but way cooler.
You've got that right, Aldo. Today we're going to talk about the life cycle of a star, also known as stellar evolution. Did you know that stars are born, live their lives, and then, well, they kind of retire in a super cool way?
Retire? Like, do they sit on a cloud and sip star juice?
Not exactly, Aldo, but close. Let's start from the very beginning where a star is born. It all starts in a giant cloud of gas and dust called a nebula.
Ooh, a nebula! That sounds like the best kind of bubble bath ever.
It does sound fun, doesn't it? So, inside this nebula, things start to get squished together because of something called gravity. It's like a big cosmic hug. The superhot gas starts rotating, which is known as a protostar. The protostar grows by adding gas and dust from the nebula. When enough gas and dust get squeezed together, they get hotter and hotter until, bam, a star is born.
A star is born. Just like that?
Just like that. Now, once a star is born, it spends most of its life in a phase called the main sequence. This is when the star is happily shining bright, burning hydrogen to make energy. It's like the star's childhood and teenage years all rolled into one.
So, stars are like big, glowing teenagers in space? Do they have space acne?
Ha ha ha. Not quite. But they do have spots called sunspots. Anyway, after a star has burned up most of its hydrogen, it starts to change. If it's a small star, like our sun, it will become a red giant. That's when the star swells up really big, kind of like a pufferfish in space.
A space pufferfish? That's hilarious. Do they puff up because they're mad?
Not mad, just out of fuel. After being a red giant, the star will blow off its outer layers and leave behind a small, dense core called a white dwarf. Eventually, the white dwarf will cool down and become a black dwarf. A star that's no longer shining.
Wait, so it's like the star gets sleepy and takes a forever nap?
Exactly, Aldo. But if the star is really, really big, it has an even more exciting ending. It can explode in a supernova, one of the biggest explosions in the universe. After the explosion, what's left can either become a neutron star or even a black hole.
Whoa! So big stars go out with a bang, huh? That's super cool and kinda loud.
Let's talk about some super cool star facts that'll make you say, wow.
I love fun facts. Lay 'em on me, Sonia. Did you know that spiders can spin webs faster than a shooting star?
That's a fun fact about you, Aldo. But let's dive into some star-studded trivia. First up, did you know that the hottest stars in the universe are blue?
Wait, what? Aren't stars supposed to be yellow like the sun? Blue stars must be the rebels of the star world.
They sure are. Blue stars burn at temperatures over 30,000 Kelvin. They're super hot and super bright, but they burn through their fuel really quickly, so they don't live as long as cooler stars like our sun.
Whoa! So they're like those race cars that go super fast but need pit stops all the time.
Exactly.
How hot is our sun?
The photosphere of our sun, or the outer layer, burns at 5,772 Kelvin, but the core can get up to 7 million Kelvin. Kids, how many stars do you think there are in the universe?
I think there has to be more than 1 million. What do you think, kids?
Those are good guesses, kids. Astronomers estimate that there are 1 septillion stars in the universe. A septillion is a 1 followed by 24 zeros.
I'd like to have a septillion V-Bucks or Robux.
I'm not sure there would be enough to buy if you had that much game currency.
Our Milky Way galaxy contains more than 100 billion stars. That makes me realize my biggest problems are relatively small.
Yes, indeed. Just one look at the night sky can give us a whole new perspective on life. Here's another fun fact. Did you know that our sun is actually a pretty average star? It's called a yellow dwarf. There are stars out there that are over 100 times bigger than our sun.
100 times bigger? That's like comparing me to a giant tarantula. Yikes!
Yep, and those giant stars are called supergiants. They're so big that if one replaced our sun, it would reach out past the orbit of Jupiter.
Wow! That would make for some supersized sunburns. What strength sunblock would I need for a supergiant?
No kidding, probably SPF 1 million. Here's another cool fact. Stars don't twinkle because they're twinkling. They appear to twinkle because their light is passing through the Earth's atmosphere. It's like the atmosphere is playing a little game of peekaboo with the stars.
So stars are steady, but the atmosphere is just being playful? That's good to know. I thought stars were just showing off.
They do like to shine, but they're pretty steady up there. Kids, do you think we could live without the sun?
That's an interesting question, Sonia.
Great guesses, kids. That's right. We need the sun to survive. Without the sun, our solar system would not stay together, and we'd float off into space.
The sun also provides heat to make the Earth warm enough for us to live here.
That's right, Aldo. Also, without the light from the sun, there would be no plants or animals on Earth. We wouldn't have food and we wouldn't exist either.
Wow, thank the sun then. Dear sun, thank you.
The sun has periods of ups and downs with solar activity such as solar flares and sunspots. These cycles repeat and last for about 11 years. We call these cycles solar cycles. Here is another question, kids. If we divided up the solar system, including the sun, planets, asteroids and meteors into 100 parts, how many parts would be entirely from the sun?
Interesting way to put the question, Sonia. What do you think, kids?
Those are good answers, kiddos. The sun contains most of the material in our solar system. The sun would make up 99 out of the 100 parts. Or we say, the sun makes up 99% of the material in our solar system.
Hey kids, can you guess what the fastest thing in the whole universe is? Great guesses, kids. While I am quite fast myself, the correct answer is light.
Even with light being the fastest thing in the universe, it still takes light about 8 minutes and 20 seconds to reach Earth from the sun.
What is the most interesting thing that you've learned about stars, Sonia?
Scientists have discovered that stars are like cosmic factories, producing the building blocks for everything in the universe. Inside their fiery cores, stars turn simple elements, like hydrogen, into heavier ones. These heavier elements, such as carbon and nitrogen, are essential for life as we know it. However, it's the really massive stars that have the power to create even heavier elements like gold, silver, and uranium. When these giants explode in supernovas, they scatter both the elements they've stored and the new ones they've just made across space, enriching the universe with their cosmic creations.
Wow, gold and silver are made inside of massive stars? That's so cool. Remember that the next time you see a piece of gold or silver, kids? Well, I guess that goes for anything you see. Thanks again, stars.
And here's a wild one. Some stars have planets orbiting around them, just like our sun has Earth and the other planets.
I want to believe. Maybe there is some cool life out there on another planet. Can we visit one of these planets?
Maybe one day, Aldo. Scientists are still discovering new planets all the time, and who knows? Maybe one of them will be just right for us to visit someday.
I'll pack my spacesuit and snacks. Oh, tell them about binary stars. That's one of my favorites.
Great idea, Aldo. A binary star system is when two stars orbit around each other. It's like a cosmic dance with two stars spinning around in space together. And sometimes, there are even triple star systems. Imagine 3 stars all dancing together.
That's like a star party. I'd love to see that.
Me too, Aldo. And did you know that the closest star to us, after the Sun, is Proxima Centauri? But even though it's the closest, it's still over 4 light years away. That means it takes light over 4 years to travel from that star to us.
4 years? That's like forever. But I guess stars are worth the wait, huh?
Absolutely, Aldo.
Does that mean that the light that we see from Proxima Centauri is 4 years old by the time we see it?
That's correct, Aldo. It's crazy to think about, right?
Yeah, luckily my room light is much closer than stars. It'd be crazy if I turned off a light and had to wait 4 years for my room to get dark.
Haha, yeah, Aldo. Seeing stars in the sky is like looking back in time. Good thing we don't have to wait years for lights to turn off or on here.
If you thought that was interesting, wait till you see what's next. Or not. Let's find out.
Now that we've learned all about stars in the sky, let's take a journey back in time to see just how important stars have been for humans throughout history.
Ooh, a time travel adventure? Count me in. Did people back in the day use stars to find hidden treasure?
Well, not exactly hidden treasure, Aldo, but they did use stars to find their way around. For thousands of years, people have looked up at the stars to navigate the seas, travel across deserts, and even find their way home. Before we had GPS and maps, stars were like the original guides in the sky.
So stars were like the first ever road signs? That's pretty cool. Which stars did they use?
Great question, Aldo. One of the most famous stars people used is the North Star, also known as Polaris. The North Star is almost directly above the North Pole, so it's been a reliable way for travelers in the Northern Hemisphere to figure out which direction is north. Sailors, explorers, and adventurers all used the North Star to navigate the open seas and unknown lands.
Wow, the North Star must have been like the ultimate compass. No batteries needed.
Exactly. In the Southern Hemisphere, Polaris Australis is Polaris's dimmer counterpart. Stars weren't only used for navigation, stars were also super important in helping ancient civilizations keep track of time. People noticed that different stars and constellations appeared in the sky at different times of the year. By watching the stars, they could figure out when to plant crops, when to harvest, and even when to celebrate important festivals.
So stars were like the first ever calendar too? That's amazing. They must have had star parties every time something cool happened in the sky.
They did. Ancient cultures built entire stories and myths around the stars. The constellations, which are groups of stars forming patterns, were often connected to legends and gods. For example, the ancient Greeks saw the constellation Orion as a great hunter, and the Egyptians built their pyramids to align with certain stars because they believed it would help their pharaohs in the afterlife.
Whoa, so stars were like guiding lights, calendars, and storybooks all rolled into one. That's a lot of responsibility for some shiny dots in the sky.
It sure is. And even today, stars continue to inspire us. They remind us of our place in the universe and have been the starting point for many scientific discoveries. By studying the stars, humans have learned so much about space, time, and the nature of the universe itself.
And let's not forget, stars also help us make wishes. How cool is that?
Absolutely, Aldo. Stars have always been a symbol of hope, guidance, and wonder. Whether it's guiding ancient travelers across oceans or inspiring dreams for the future, stars have played a huge role in shaping our history and our imagination.
So, whenever we look up at the stars, we're not just seeing pretty lights. We're seeing the same stars that guided explorers, marked the seasons, and told stories for thousands of years. That's like having a cosmic connection with the past.
You got it, Aldo. The stars connect us to history, to each other, and to the vast universe beyond. So next time you gaze up at the night sky, remember the incredible journey those stars have taken with humanity.
And if you ever get lost, just look for the North Star. It's like having an ancient navigator right above you. Recalculating. Make a U-turn. Recalculating. Recalculating.
All right, star adventurers, let's dive even deeper. Ever wondered what's inside a star? Imagine peeling an onion. Yep, stars have layers too. And just like an onion, each layer has something important going on. Let's take our very own sun as an example.
Ooh, I love onions. Wait, I love the sun. So, what's inside?
First, at the very center of the sun is the core. This is where all the magic happens. The core is like a giant nuclear furnace where hydrogen atoms smash together to form helium, creating a ton of energy. This energy is what makes the sun shine so brightly.
Whoa, so the sun is like a super powerful light bulb, but way cooler.
Well, actually, it is way hotter, Aldo. Surrounding the core is the radiative zone. In this layer, energy from the core slowly makes its way outwards as light, or photons. It takes a long time, sometimes millions of years, for this energy to move through the radiative zone.
Millions of years. That's like older than my great-great-great-great-grand spider.
Haha, yes, it's super old. After the radiative zone comes the convective zone. Here, hot plasma rises, cools as it nears the surface, then sinks back down to be heated again. Kind of like a cosmic lava lamp.
So the sun is also a giant lava lamp. This just keeps getting cooler.
It sure does. And finally, we reach the sun's surface, called the photosphere. This is where the sunlight we see actually comes from. Above the photosphere is the chromosphere and the corona. These are part of the sun's atmosphere. The corona is that beautiful, glowing halo you see during a solar eclipse.
Wow, Sonia, stars are like the ultimate combo of science and magic.
Absolutely, Aldo, and that's why learning about them is so amazing.
I learned that corona means crown. Did we name stars coronas after crowns?
Yes. Each layer of a star has a unique role, and together they create the brilliant light that reaches us all the way here on Earth.
If you were expecting a smooth transition, think again. Here we go.
All right, star explorers, let's dive into something super cool, how we classify and rate stars. Did you know that not all stars are the same? In fact, scientists have a whole system to categorize them.
Oh, so it's like a star competition? Do they get scores for being the brightest or the bluest?
Sort of, Aldo. Scientists use a classification system called the Morgan-Keenan, or MK system, to organize stars based on their temperature, color, and brightness. The system uses letters O, B, A, F, G, K, and M to classify stars, with O being the hottest and bluest, and M being the coolest and reddest.
Wait, so the stars have secret code names? That's awesome! So what about our sun? What's its star code?
Great question. Our sun is classified as a G-type star, specifically a G2V. The G tells us it's a yellow star, and the 2V means it's in its main sequence phase. Remember, that's the part of a star's life when it's shining steadily and burning hydrogen.
So, our sun's like a golden superstar in the middle of its career? Nice!
Exactly. And stars also get classified by their brightness using something called the magnitude scale. There's apparent magnitude, which is how bright a star looks from Earth, and absolute magnitude, which is how bright the star really is if you were standing a certain distance away from it.
So, some stars might look super bright just because they're close, but they're actually not as bright as stars that are farther away? Sneaky!
You got it, Aldo, and there's more. Stars are also rated by something called their luminosity, which is a measure of how much energy they give off. Bigger stars usually have higher luminosity because they burn more fuel and shine brighter.
So, if a star's got high luminosity, it's basically the star of the year, right? A real show-off.
That's one way to put it. Scientists use these classifications to learn more about how stars live and evolve. And it helps them understand what kind of stars might have planets orbiting around them, or which ones might be getting ready for a supernova.
Wow, stars have so much going on. I thought they just sat up there twinkling, but they've got ratings, classifications, and everything. Do they get trophies too?
No trophies, but they do get the honor of lighting up our night sky and helping scientists unlock the mysteries of the universe.
That's way better than a trophy. So next time I look up at the sky, I'll know that each star has its own cool story, classification, and maybe even a top-notch rating.
That's right, Aldo. The next time you see the stars, remember how unique each one is. Whether they're blue giants or red dwarfs, every star has its own place in the universe, and its own story to tell.
And who knows, maybe one day we'll find a new star and get to give it its very own rating. That'd be stellar.
Stellar indeed.
Thanks for explaining, Sonia.
Anytime, Aldo. Thanks for watching Star Explorers. Keep exploring, keep wondering, and keep looking up at the stars. They've been lighting our way for centuries, and they'll keep shining for centuries to come.
And don't forget to give this video a 5-star rating if you loved our starry adventure today. And of course, hit that like button and subscribe for more fun and learning with us.
Thanks for joining us on this journey through the stars and history. See you next time, Star Explorers.
ancient, belonging to a time long ago in history. Calendar, a chart that shows the days, weeks, and months of the year. Celebration, a special time or event where people have fun. Compass, a tool that shows direction. Constellation, a group of stars that form a pattern in the night sky. Discover, to find out or learn something new. Explorer, a person who travels to new places to discover things. Festival, a celebration or special event that happens at certain times. Harvest, the time when crops are gathered from the fields. Mysterious, something difficult to understand or explain. Navigate, to find the way to get to a place when you are traveling. Pharaoh, a ruler in ancient Egypt. Shiny, something that is bright or reflects light. Universe, all of space, including all of the stars, planets, and everything in them. Prefix, exo, as in exoplanet, from Greek exo, meaning outside or external. Prefix, pre, as in prehistoric and preview, from Latin pre, meaning before. Prefix, re, as in return and recycle, from Latin re meaning back or again. Prefix, super, as in supernova and superstar, from Latin super, meaning above or beyond. Prefix, uni, as in universe and unicycle, from Latin unus, meaning one. Root, astro, as in astronomy and astronaut, from Greek astron, meaning star. Root, cycle, as in recycle and life cycle, or bicycle, from Greek kyklos, meaning circle or wheel. Root, form, as in transform and formulate, from Latin formare, meaning to shape. Route, nav, as in navigate and navigation, from Latin navigare, meaning to sail. Root, scribe, as in subscribe and describe, from Latin scribere, meaning to write. Suffix, ist, as in scientist and biologist, meaning a person who practices or is concerned with something. Suffix, as in explorer and discoverer, meaning one who or a person who does. Suffix, lie, as in brightly and easily, turns adjectives into adverbs, meaning in a manner. Suffix, use, as in mysterious and famous, meaning full of, or having the quality of. Suffix, tion, as in celebration, navigation,